Welcome to the Deep Sleep channel. Tonight we're traveling through deep time. We're going to witness 5 moments when life on Earth nearly ended. 5 catastrophes so severe that the vast majority of species died. 5 extinction events that reshaped the entire planet and everything living on it. But this is not a story about death and despair. This is a story about resilience. This is a story about how life survived the unsurvivable. This is a story about how every time the Earth nearly died, life found a way to recover, to adapt, to flourish again. These are the big 5 extinction events: the Ordovician-Silurian extinction, the late Devonian extinction, the Permian-Triassic extinction, the Triassic-Jurassic extinction, and the Cretaceous-Paleogene extinction that killed the dinosaurs. Close your eyes. Let yourself drift through 450 million years of Earth's history. Let yourself witness catastrophe and survival. Let yourself understand that life is resilient beyond measure, that extinction is not the end, that from devastation, new worlds can emerge. Part 1. The deep time perspective. Measuring time in millions of years before we talk about the extinctions, we need to understand deep time. We need to train our minds to think in timescales that are difficult for humans to grasp. 1 million years. That's 1 million years, longer than all of human civilization, longer than all of recorded history, longer than all of prehistory. 1 million years. Just 1 million. The big 5 extinctions happened millions of years ago, hundreds of millions of years before humans existed, before mammals dominated, before dinosaurs, way back when the Earth was young, when life was different, when the world was alien to us. The most recent extinction, the one that killed the dinosaurs, happened 66 million years ago. That's 66 million years longer ago than we can meaningfully comprehend. But in the timeline of Earth's history, 66 million years ago is recent. It's the blink of an eye in geological time. To understand the big 5 extinctions, we have to train ourselves to think in these massive timescales. We have to understand what seems permanent, a species, an ecosystem, an entire world, is temporary. Everything changes. Everything evolves, everything eventually dies. The concept of extinction. Extinction is the permanent disappearance of a species. When the last member of a species dies, and there are no more individuals of that species alive, the species is extinct. Extinction is natural. It happens all the time. Scientists estimate that 99.9% of all species that have ever lived on Earth are now extinct. Extinction is the normal state of being on Earth. Most species that exist go extinct. But mass extinction is different. A mass extinction event is when a large number of species go extinct in a relatively short period of time. Not just a few species, not the normal background extinction rate, but many species, many ecosystems, many ways of life, all disappearing. The Big 5 were the most severe mass extinction events in Earth's history. They were moments when the normal rules stopped applying, when death came on a planetary scale. Part 2. The Ordovician-Silurian extinction. 445 million years ago, the world of the Ordovician. Imagine the Earth 445 million years ago. The continents are in different positions. There's no life on land, no plants, no animals, no trees. All life is in the oceans. The oceans are full of life. Trilobites dominate the sea floor. There are bizarre creatures, nautilus-like animals, strange fish with armor, creatures that barely resemble anything alive today. There are algae and seaweed. There are corals. Life is abundant in the oceans. Life is diverse. The world is warm. The climate is stable. Life is flourishing. The Ordovician period is a time of diversity and abundance. Species die. Life in the oceans persists, changed and diminished, but persistent. And then something remarkable happens. The ice age ends. The temperature rises. The sea level rises. The oceans recover. And in those recovering oceans, life explodes again. New species evolve. New ecosystems form. Life diversifies. The ocean is repopulated, but with different creatures. New forms of life emerge. The Ordovician Silurian extinction killed perhaps 85% of all species, a catastrophe beyond measure. But life survived. Life adapted. Life flourished again. Part 3. The Late Devonian Extinction, 375 to 359 million years ago. The world of the Devonian. Fast forward 70 million years. The world has changed. Life has diversified. The oceans are full of fish, shark-like creatures, strange armored fish, the first rays and sharks as we know them. Fish are the dominant form of animal life. The land is beginning to be colonized. Plants have evolved. The first forests are beginning to grow. The first arthropods are crawling on land. Life is beginning to leave the oceans. The long extinction. The Late Devonian extinction is different from the Ordovician Silurian extinction. It's not one catastrophic event. It's a series of extinction pulses over about 16 million years. There are multiple causes: climate change, ocean acidification, oxygen depletion in the oceans, asteroid impacts possibly. The causes are complex and not fully understood, but the result is clear. Species die. The armored fish vanish. Many species of sharks die. The corals are devastated again. Life in the oceans is hit hard. The extinction is spread over millions of years, but the effect is catastrophic. Perhaps 75% of all species die. The oceans, which had recovered and flourished after the Ordovician Silurian extinction, are devastated again. The significance. The Late Devonian extinction is the extinction of the armored fish. The creatures that dominated the oceans in the Devonian disappear. They are replaced by other fish, the ancestors of modern fish. It's a turning point. The era of one type of creature ends. The era of another type begins. The baton of dominance passes. Part 4. The Permian-Triassic extinction. 252 million years ago, the world extinction. The Permian-Triassic extinction is the worst. It's the most severe mass extinction event in Earth's history. It's sometimes called the Great Dying. 252 million years ago, at the boundary between the Permian period and the Triassic period, something catastrophic happened. The world of the Permian. The Permian is a time when the continents have mostly come together into one supercontinent, Pangaea. The climate is extreme, very hot, very dry. Deserts cover huge areas. The interior of the supercontinent is a harsh place, but life exists. In the oceans there is life. On land there is life. Insects dominate the land. The first reptiles are evolving. Synapsids, the ancestors of mammals, are the largest land animals. Life persists. The catastrophe. Then, something happens. Scientists are still debating the exact cause, but the leading theory involves massive volcanic eruptions in what is now Siberia. The Siberian Traps eruption is one of the largest volcanic events in Earth's history. Vast amounts of lava pour out. The eruption lasts hundreds of thousands of years. It pours greenhouse gases into the atmosphere: carbon dioxide, methane, sulfurous compounds. The atmosphere changes. The temperature rises dramatically. The oceans warm. Ocean circulation slows. Oxygen levels in the oceans plummet. The oceans become anoxic, lacking oxygen. At the same time, acid rain falls. The oceans acidify. Shells dissolve. Calcium skeletons become impossible to maintain. The extinction. The extinction is comprehensive. Perhaps 96% of all marine species die. Perhaps 70% of all terrestrial vertebrate species die. It's not just a few species. It's not just ecosystems. It's civilization-level catastrophe for the creatures of that time. The oceans become dead zones. Most of the creatures that lived in the oceans are gone. The coral reefs vanish completely. The diversity of the oceans is stripped away. On land, the large animals die. The synapsids are decimated. Insects are hit hard. The forests shrink. The world becomes a devastated place. The recover. Slow and difficult after the Permian-Triassic extinction, recovery is slow. It takes millions of years for life to diversify again, millions of years for ecosystems to recover, millions of years for the oceans to repopulate. But recovery does happen. Life persists. New species evolve. New ecosystems form. Life diversifies again. And this recovery is important because from the survivors of the Permian-Triassic extinction, the dinosaurs will eventually evolve. Part 5. The Triassic-Jurassic extinction 201 million years ago. The Triassic world. The Triassic period is a time of recovery. After the devastation of the Permian-Triassic extinction, life has been rebuilding. New forms have evolved. New ecosystems have formed. The dinosaurs are beginning to emerge. They're not dominant yet. Synapsids still exist, but dinosaurs are appearing. They're evolving. They're adapting. The world is warming. The climate is changing. Pangaea is beginning to break apart. The continents are separating. New oceans are forming. The extinction event. Around 201 million years ago, another extinction event occurs. The cause is debated, but likely involves massive volcanic eruptions, climate change, and ocean acidification, similar causes to the Permian-Triassic extinction. The extinction is less severe than the Permian-Triassic. Perhaps 50% of species die, but it's still a major extinction event. Large animals are hit particularly hard. The remaining synapsids die. Many marine species die. The opening for dinosaurs. But here's what's remarkable. The extinction opens a door. It clears the landscape. It removes the competitors, and it allows dinosaurs to flourish. In the Jurassic period, which follows the Triassic, dinosaurs become the dominant land animals. They evolve into giants. They diversify. They become the rulers of the Earth. Without the Triassic-Jurassic extinction, dinosaurs might not have had the opportunity to dominate. The evolutionary landscape might have been different. Life might have followed a different path. Part 6. The Cretaceous-Paleogene extinction, 66 million years ago. The Cretaceous world. The Cretaceous period is the final period of the Mesozoic era. It's the age of dinosaurs. Dinosaurs are the dominant land animals. There are hundreds of species. They're diverse. They're successful. They've dominated for over 100 million years. The world is warm. The climate is stable. The continents are in positions more similar to today, but still different. Flowering plants are diversifying. Mammals are small and hiding in the shadows of the dinosaurs. Birds have evolved from dinosaurs. Life is flourishing. The dinosaurs have no idea that their dominance is about to end. The impact. 66 million years ago, an asteroid 10 kilometers in diameter strikes the Earth. It strikes the Yucatan Peninsula in what is now Mexico. The impact is catastrophic. The explosion is unimaginable. The asteroid explodes in the atmosphere. The energy released is equivalent to billions of nuclear bombs. Everything within hundreds of kilometers is instantly destroyed. Forests are incinerated. The ocean is vaporized. Rock is melted. A tsunami spreads across the oceans. Wildfires erupt globally as hot ash and debris fall from the sky. Darkness falls over the planet. The sky becomes black. The sun is blocked by ash and dust. The aftermath. In the darkness, photosynthesis stops. Plants die. The primary producers of the food chain vanish. Without plants, herbivores starve. Without herbivores, carnivores starve. The temperature drops. It's suddenly cold. After millions of years of warmth, it's suddenly freezing. Life that has adapted to warmth dies from cold. It lasts weeks. It lasts months. The darkness and cold last for months. The asteroid winter. The impact winter. The extinction. Species die. Massive extinctions occur. Perhaps 75% of all species die. The dinosaurs, all of them except birds, die. The large reptiles die. The large mammals die. The world is devastated. but some species survive. Small mammals survive. Birds survive. Some reptiles survive. Some fish survive. Some insects survive. Life persists, but changed and diminished. Part 7. The pattern in what the extinctions teach us. The causes. The big five extinctions had different causes. Ordovician Silurian, glaciation, climate change, ocean oxygen depletion 2, late Devonian, climate change, oxygen depletion, possibly asteroid impacts, ocean acidification, Permian Triassic, massive volcanism, greenhouse gases, ocean anoxia, ocean acidification, Triassic Jurassic, volcanism, climate change, ocean acidification, Cretaceous Paleogene, asteroid impact, volcanism, darkness, cold, Part is potage on the side of catastrophes, but despite different causes, there's a pattern. Environmental change, rapid change, change that happens faster than life can adapt, climate change, chemical changes in the oceans, physical catastrophes, the common theme, change and adaptation. What all the extinction events have in common is that the world changes, the climate changes, the oceans change, the atmosphere changes, the physical environment transforms, and when the environment changes rapidly, species die. The species that are adapted to the old conditions don't adapt fast enough to the new conditions. They go extinct. But some species do adapt. Some species survive, and those survivors become the basis for new life, new diversity, new ecosystems. The recover pattern. After each extinction, there's a recovery period. It takes millions of years, but life returns. Diversity increases. New species evolve. New ecosystems form, and the recovered world is different from the pre-extinction world. The species are different. The ecosystems are different. The dominant creatures are different. Each extinction reshapes life on Earth. Each extinction opens doors for new forms of life to emerge. Each extinction is a turning point in the history of life. Part 8. The resilience of life. Why life survives. How does life survive these catastrophes? How does anything persist when 75% or 96% of species die? The answer is diversity. The more diverse life is, the more likely that some species will survive any particular catastrophe. A catastrophe that kills 75% of species still leaves 25% alive. Those survivors diversify and repopulate. Also, the survivors are often the species that are generalists, species that can eat many types of food, that can tolerate a wide range of conditions, that are flexible and adaptable. Life doesn't survive because any individual species is particularly strong or clever. Life survives because it's diverse and varied and distributed. There's always something, somewhere, that can survive. The speed of recovery. Recovery is slow. After the Permian Triassic extinction, it took millions of years for oceans to recover. It took millions of years for forests to regrow. It took millions of years for life to diversify again. But in geological time, millions of years is not that long. Millions of years is the normal timescale of evolution. Millions of years is how long it takes for species to evolve. So recovery happens. It's slow, but it happens. Life rediversifies. Life reestablishes. Life thrives again. The opening of possibility. Each extinction event is catastrophic, but each extinction also opens possibilities. It removes the incumbents. It clears the landscape. After the Permian Triassic extinction, dinosaurs evolved. They might not have if the synapsids had continued to dominate. After the Triassic-Jurassic extinction, dinosaurs became the rulers. They might not have if other creatures had continued to dominate. After the Cretaceous-Paleogene extinction, mammals diversified. They became the dominant land animals. Without the extinction of dinosaurs, mammals might still be small creatures hiding in the shadows. Without these extinctions, the world would be different. Without these extinctions, humans might not exist. Part 9. What the Big Five teach us. The impermanence of dominance. The dinosaurs dominated for 165 million years. That's longer than any mammal has dominated. That's an incredibly long time. And then in an instant they were gone. This teaches us that dominance is temporary, that being the most successful species doesn't guarantee survival, that the world can change in ways we don't expect. The synapsids dominated for millions of years before the dinosaurs, and then they were gone. Everything is temporary. The power of randomness. None of the big five extinctions were inevitable. They were caused by specific events: volcanic eruptions, climate changes, asteroid impacts. If those specific events hadn't happened, the extinctions wouldn't have happened. If the asteroid hadn't hit 66 million years ago, dinosaurs would still be alive. The world would be completely different. Life would have followed a different path. This teaches us about the power of randomness. Life is shaped by random events. The shape of the world is determined by chance. We exist because of a specific asteroid impact at a specific time. The resilience of life. Despite 5 mass extinction events, life persists. Despite catastrophes that killed the vast majority of species, life survived. Life adapted. Life flourished. This teaches us about the remarkable resilience of life. Life is tough. Life is adaptable. Life finds a way. Even in the most extreme conditions, life survives. Even in the oxygen-depleted oceans of the Permian-Triassic extinction, some species survived. Even after the asteroid impact that killed the dinosaurs, life recovered. The connectedness of life. The big 5 extinctions were catastrophes caused by nature. Asteroid impacts, volcanism, climate change, caused by natural processes. The 6th extinction is a catastrophe caused by humans. We are deliberately and accidentally driving species to extinction. We are changing the climate. We are destroying habitats. We are poisoning the oceans. This is different. For the first time in Earth's history, the extinction event is caused by one species, by us. The responsibility and hope. But here's what's important. Unlike the big 5 extinctions, the 6th extinction is something we can change. We can alter our behavior. We can reduce our impact. We can protect species and habitats. We can address climate change. The big 5 extinctions happened whether species wanted them to or not. There was nothing the creatures of those times could do. But we can do something. We have the power to change the course of this extinction event. And just as life survived the big 5 extinctions, life will survive the 6th extinction. But what form that life takes, how diverse it is, how rich and varied, that depends on the choices we make now. Farewell from the Deep Sleep Channel. Thank you for journeying through deep time with us. Thank you for witnessing the big 5 extinctions. Thank you for contemplating the resilience of life and the impermanence of dominance. As you sleep tonight, carrying the story of the extinctions with you, think about what they mean. Think about the vast timescales of Earth's history. Think about the creatures that lived millions of years ago. Think about the catastrophes that reshaped the world. Think about the survival and adaptation that allowed life to persist. Think about impermanence. Think about change. Think about the fact that nothing is stable, that everything evolves, that the world is constantly transforming. And think about resilience. Think about the fact that despite catastrophe, life survives. Despite extinction, new forms emerge. Despite loss, there is recovery. You are part of this story. You are descended from creatures that survived extinctions. You are part of life on Earth. You are part of deep time. Sleep knowing that you are resilient. Sleep knowing that you are part of something vast and ancient and ongoing. Sleep knowing that life, over and over again, has chosen survival and adaptation and continuation. Sleep well, knowing that even in the darkest moments, life finds a way. Good night from the Deep Sleep Channel. Sleep well.